Hello everyone, this is Luna. Today, we'll use geometry nodes to create woven fiber material, allowing easy adjustment of tile count, curve density, deformation, and more. Please subscribe if you're interested in scientific visualization. Let's begin the practical workflow now. Delete all objects, clear unused data, create a new cube, and create geometry nodes. Press Shift+A to create nodes, or use shortcut Shift+Z. We start from a basic curve line. Set its x value from -0.5 to 0.5. Later we want to deform the line, so the line needs enough points. Use resample to set the line's points to 100. Next we will use trigonometric functions to deform this line. I assume you already understand sine functions well. I have written the formula on the screen. Add position node and split it, apply the sine function to its x value, and connect the result to the point's z value. You can set frequency and amplitude through 2 multiplications before and after sine. However, I want to set parameters more clearly and use one value to control frequency. Create a value, rename it to frequency, and set its value to 1. Here I spelled an extra n, please ignore it. One cycle is 360 degrees, we need to multiply by 360. Sine function processes radians, we need further conversion. This value can clearly control the repeatability of the curve line. Next we want to duplicate this line. We use a repeat zone. First move the input line on the y-axis, then merge it with the original line. After repeating several times, we get a line array. But what should the spacing between lines be? We need to clarify the mathematical relationship between lines. The line spacing should equal half cycle. So first multiply frequency by 2, then divide 1 by this value, obtaining an offset value. I mark this node as green, because later nodes all need to use this value. This is the charm of procedural workflow. Now we connect the green node to the transform node's offset, obtaining a uniform array. For an accurate woven shape, lines need staggered offsets. How to select alternating lines? We can use the modulo function. For curve index being odd, modulo 2 always equals 1. For even, it equals 0. We can multiply the offset value by the modulo result, thus achieving precise staggered offsets. The specific offset value should also use my previously set green node. I forgot to connect it. Ensure you connect it. Now we need to duplicate one layer and rotate it. But this array is not at world origin. We need to make it return to world origin. We can first calculate half of the bounding box's diagonal, then add the minimum value. This gives the distance from object center to world origin. Multiply this by -1 as offset value to center the object at world origin. Now we need to duplicate one layer and rotate it 90 degrees. The line's peaks overlap completely, so we need to offset again. Fortunately, we already set the offset value earlier. We can directly connect it. Thus we obtain the basic shape of woven fiber. Due to the previous offset, its edges have some issues. We need to use a cube to trim it. The specific principle is this: let each point raycast along its own position. If it hits the cube, the point is inside, otherwise outside. We can use this is-hit result to evaluate deletion. Delete unhit points to obtain a clean shape. Now I quickly connect the nodes. Now we need to increase line quantity. First duplicate splines, but they all stay in one position. We need to offset each line left or right. How to set left or right vectors? We can use cross product. Cross the curve tangent with the up vector to get the vector. Multiply by a random value to offset lines sideways. The random seed should continue using curve index. We notice after offsetting, some areas are wide and some narrow. This is because we missed the normalize step. Convert these lines to models using curve to mesh. We can lower the profile curve's resolution because more lines cause lag. Now I also want these lines to have vertical offsets. We can multiply the up vector by each line's generated random value. Now I want central lines more chaotic. We can introduce an icosphere and use geometry proximity to read distance from line points to this sphere. We can preview it. Use color ramp to invert it and adjust distance. Add noise to offset its position. Noise first needs map range to adjust values to -1 to 1, next multiply it by the distance to control position offset range. Now curves appear unsmooth. We can set curve type to increase smoothness. We also need different noise values for each curve. So connect curve index to noise's W value. This makes line shapes more beautiful. Create a spotlight and adjust parameters appropriately. Reduce curve thickness, increase quantity to 200. This is the detailed procedure for creating procedural woven fiber. If you have questions, please leave comments. I will reply promptly. Thanks for watching. See you in the next video.